Basics, even and odd functions, increasing, decreasing, absolute and local maximums and minimums. For even and odd functions, it says in an even function, f of negative x equals f of x. Graphically, an even function is symmetric about the y-axis. In an odd function, f of negative x equals the negation of f of x. Graphically, that would be symmetric around the origin. We typically look at it algebraically if the functions are even, odd, or neither. So you'd have to do f of negative x. So you plug negative x in anywhere you see an x. This is negative x cubed. A negative to the third power is negative. Then here, negative times a negative is positive. Okay, so comparing it to the original, the 3x to the cube is negated, opposite signs, so is the 5x. So this negated will give me that. So this is odd. If I do f of negative x here, negative 3, negative x squared minus 5, that's negative 3 times positive x squared minus 5. Negative squared is positive. This is the exact same thing that I started with. It's same. So it's even. F of negative x. We're going to plug negative x into x and then simplify. So a negative cubed is negative times a negative is positive. Now, here's one thing that people get a little confused about. What you have to think about with fractions. If I have 3/4, and if I want the opposite of 3/4, I'm going to either negate the 3 or negate the 4, or I could just put a negative out in front. But only one, either numerator or denominator, is negated. So if I compare this to here, the numerator is negated. The denominator is exactly the same. So that is an opposite, which means this is odd. So because it's a fraction, either the numerator or denominator needs to be negated, not both. Because if both were negated, if I had negative 3 over negative 4, that's positive 3/4. That would be the same as the original. So you don't want that. You want just one negated. Okay, and last one of this type. We get x squared plus x squared minus x minus 2. So let's see. In the numerator, that's the same, that's opposite, that's negated, that's the same, that's opposite, that's the same. So there's really no where the top's negated or the bottom's negated. It's kind of a mix. So this would be a case where it's neither. It's not the exact opposite. It's not the same. Okay, so for local and relative maximum, and this is important. To determine whether a function is increasing or decreasing, you must trace the curve from left to right. Okay, so a local or relative max, those words are used interchangeably. Sometimes they'll say local max, sometimes they'll say relative max. Is a maximum at a localized place in the graph. Or we could say the graph reaches a max in a specific area. So it might not be the overall highest Y value, but it's the highest Y value in a certain area. Okay. So for local maximum, the graph of F changes from increasing to decreasing. For a local min, sorry, I just got to pause here for a minute. I had to plug in this laptop or it's about to die. Okay, sorry about that. I was about to lose everything. Okay, so a local or relative minimum is a minimum in a localized place in the graph. The graph reaches a min in a specific area. So it might not be the overall lowest point in the graph. It just means at a certain place or area of the graph, it reaches a minimum. For local mins, the graph changes from decreasing to increasing. So if you think about it, if a graph is decreasing and then it turns around and increases, that's a local min. And for a local max, if it's increasing and it turns around and decreases, that's a local max. Okay. Now, absolute extrema, that's the absolute highest value. So for absolute maximum value, that's going to be the highest Y value. Absolute minimum value, lowest Y value. Okay, M behavior using limits. When you are asked to describe the M behavior of a graph, you are being asked to look at what is happening to Y as X approaches infinity or negative infinity. So we are going to use limit notation. Limit of f of x as x approaches infinity equals something. Limit of f of x as x approaches negative infinity equals something. Now, I know last year you might have just wrote some abbreviated version of that, like y approaches this as x approaches that. We're not going to do that. We're kind of getting a little more advanced. We're going to use limit notation. So just make sure you're doing that. Okay, state the domain range where the function has a local max or maximums, local min or minimums, absolute maximum, absolute minimum. Where is it increasing or decreasing? Okay. So let's start. I'm going to put domain up here. All right, so let's see. My x's are going from 1 over to 5. So I'm going to do hard bracket 1 to 5. My range is going from 1 to 4. So it is, let's see, it's decreasing here from 1 to 2. Then it's increasing from 2 to 3. And then it's decreasing from 3 over to 5. So here, using X values. I'm doing interval notation, so I'm stating an interval. All right, local maximum. Okay, I got a local max at 3, 3. I got a local min at 2, 2. Absolute maximum value is highest Y value, so 4. Absolute minimum value, absolute lowest Y value is 1. Okay, so for the next one, if we do, so again, up here, I'm going to put domain range just to save some room. Domain, since there's arrows, we're going all the way through all reals. Range, let's see, negative infinity up to the highest Y value, which is at 1, 2, 3. So it would be negative infinity to 3, hard bracket. Local max. Let's see, here's a place where it's increasing, then decreasing. So that would be a local max at negative 1, 2, 3, 4, 5, 1. So this is negative 5, 1. We also have one at 0, 3. We also have one at 4, 1. Local min. Well, here, negative 3, negative 2, and 2, 0. So remember, it's got to be a place where it's decreasing and then turns around and increases. Absolute min, there is none. This graph goes on to negative infinity. So infinity is not a value. Absolute max is 3. That's the highest Y value on this graph. For the increasing, decreasing, let's see, this is increasing here from negative infinity over to negative 5. Then it's decreasing from negative 5 over to negative 3. And then it's increasing from negative 3 over to 0. We're using X values. Then it's decreasing from 0 to 2. And increasing from 2 to 4. Decreasing from 4 to infinity. Okay. Sometimes people ask, why are you using soft brackets? Because technically at the maximum or at the minimum, it's not increasing or decreasing. Technically, you could use either soft or hard when you're doing increasing, decreasing. So it technically doesn't matter. Explain why the graph below has a local max, no local min, absolute max, or absolute min. Okay, so we had a local max at 4, 3, since the graph changes from increasing to decreasing. So that's how we know that's a local max. No local min because open circle at 2, 2. No absolute max because open circle at 1, 4. Or maybe I should say at y equals 4. And no absolute min because graph has open circle, or no, because graph goes to negative infinity. Okay, so find x-intercepts. We're going to let y equal 0. So g of x, I'm going to let be 0. Factor out an x squared. Set x squared equal to 0. X squared minus 2 equals 0. X squared is 2. X is plus or minus radical 2. Here, x is 0. So those are all my x-intercepts. 0, radical 2, which is about 1.4, negative radical 2, which is about negative 1.4. Y-intercepts, I'm going to do g of 0. So I'm going to let x equal 0. So it's 0 to the 4th minus 2 times 0 squared. 0 minus 0 is 0. So that's right there. Okay, then from there, I need to go to my graphing calculator. So I'm going to put in x to the 4th minus 2x squared graph. Okay, so what I have here is I have 2 local minimums. I got a local maximum there. So I'm going to do, so let's say we want to do the local mins. So this is the local extrema. So I'm going to do second, calculate minimum, which is number 3. I'm going to pay attention to the lowest y value, which looks like right there at about negative 0.99. So one place to the left, enter. One place to the right, negative 0.97, enter. Then go back to negative 0.99 for the guess. So I see it's actually at negative 1, comma, negative 1. Okay. Second, calculate minimum. Oops. Sorry, I just hit maximum, so I'll do the maximum. I'm looking for the highest y value, which is the smallest. Oh, okay. It actually goes at 0, 0. So left, enter, right, enter, back to 0, 0 for a guess. Yeah, it is 0, 0. So that's local max is at 0, 0. Second, calculate 0. Again, looking for the lowest y value. Left, enter, right, enter, back to the middle for a guess. Oops. Sorry, I did something too fast there. Okay, so left, enter, right, enter, back to the middle for a guess. 1, negative 1. Okay. Absolute max. Well, this graph doesn't have one. It goes on to infinity, so none. Absolute min is negative 1. It occurs at, I'll say, x equal 1 and x equal negative 1. I don't necessarily have to say that, but I'm just putting that in here. So we can plot our two minimums and then we make our graph. So when I have you graph in this course, I basically want you to plot x-intercepts, y-intercept, any max or mins. Now, for increasing, decreasing, this is decreasing here. So it's decreasing from negative infinity over to this x value. So I'm going to say, so it's decreasing. So I'm going to say negative infinity to this x value, which is at negative 1. Then it's increasing from negative 1 over to 0. Then it's decreasing from 0 over to positive 1. And then it's increasing from 1 to infinity. So sometimes I tell people it helps them if they kind of highlight and they say, okay, negative infinity over to 1 is where this is decreasing. Then it goes increasing. Then it's decreasing right in here from 1 to 2. And then for increasing, I would say it's increasing here from 1 or negative 1 to 0, and then increasing from 1 to infinity. So you're looking at the x values of the minimum to answer those questions. Okay, I'm going to stop there. I know we have one more example, but we can look at that. Oh, sorry, and behavior. Wait a minute. So we're going to do the limit of f of x as x approaches infinity, and the limit of f of x as x approaches negative infinity. So as x approaches infinity, as we go to the right on this graph, my y's are shooting up to infinity. As x goes to negative infinity, as I'm moving to the left on the graph, the y's are shooting up to infinity. So both of these answers are infinity. Limit means what are the y's approaching as x approaches a certain value. All right, that's it for the day.